Hello, everyone. Uh, Here for 598 office hours. Let me double check that we're streaming. The browser is not currently supported. Please use a recommended browser. I don't care, but wow. Safari is not a recommended browser. Okay. Oh, shoot. I need to sign in.
I'm gonna bash these doors over here quick. Okay.
Okay. I'm here. Okay.
Cool.
I'm here. All right, so we're in the bit of a middle, in the middle of stuff. So we already have the things due. We don't have anything. The thing coming up is the Windows module. So people in the Discord have asked any interesting insights into Windows. I'll also, let's see. All right. See if we get some people. Okay. Cool. Okay. So Windows. Honestly, I don't do a ton of work on Windows. I guess I haven't used Windows since my main OS, probably since 2010 when I started my PhD, and my advisor handed me a Mac and said, "Hey, I think this is what you're going to use as your computer." So I used it. Before then, I'd mostly run Linux for servers and those kind of things, and then had the um, then had a Windows machine basically for gaming. I think I dual booted mostly Windows and Linux on that machine. But I grew up playing a lot of Windows. Let's see. So I think the first things I want to cover is why are we going to be talking about Windows even in the first place, right? So this is kind of important because all of what you've kind of learned up until now is very Linux focused. You're learning about the Linux access control module. You learn about vulnerabilities in like commonly used Linux C libraries like glibc. You're learning a lot of like Linux specific things. Particularly when we look at, I mean, you can look at the things here. So file struct exploits, right? That specific idea. There isn't the exact, although I guess there probably is some kind of file struct object on Windows. Dynamic allocator misuse, specifically all the Tcache stuff. I don't know whether we'd have to look up if the Windows allocator uses similar things. And dynamic allocator exploitation, so being able to combine things. Now, that being said, a lot of times people will get the wrong impression when you say like, oh, this is not a whatever. This is not useful or whatever, or these type of things that you've been doing don't apply. That is definitely not true. So it's important as you go forward when targeting like a new operating system or a new type of executable. This also applies if when you're going from targeting like user space to kernel, is what are the things that I can learn about those various types of exploits that I know about? For instance, file struct exploits, right? So we taught a specific type of, hey, if you are able to overflow and control this specific file struct, then you can do these kinds of things. Well, that's not really like, that is a general purpose idea that shows up all over the place. Let me show one very cool GStreamer. This was exploit. go. This was a great article on, yeah, by Chris Evans. That's right. I couldn't remember his name exactly, but this is a fantastic um, write-up of a security vulnerability of somebody finding a heap corruption vulnerability in the GStreamer, which is a library decoder for this specific FLIC flick file format. Um, and basically, he was able to create an exploit where if you opened on a modern Linux system at the time, I think that was 1604, yeah, it's 2016, 1604, boom, it popped your system just by opening a media file. And I think even he was able to get some really cool stuff. But yeah, like just maybe like opening the file. Yeah, in Rhythmbox. Okay, but the important thing I want to show is the cool thing he talks about here is basically starting with, so figuring out the heap layout and the different objects, and then starting from there and being able to reason about, okay, now if I corrupt this specific point, this converter, we can use this other thing to write attacker supplied bytes. So essentially, this is, I believe, the struct. This is a decoder struct. So this is using decoder converter, which is right here. So he basically, as he did this, figured out that, hey, so I can manipulate the heap with my file input. I can put this specific struct where I want to use I can't remember if it was an overflow or use after free. It actually doesn't matter so much. But the fact is, like, oh, if I control this pointer and I get that to point somewhere different, then I can start sending input. So, and this is again, the really interesting thing where we found that the file struct exploits were useful by any Linux application that used a file and allocated a file from glibc. That was useful in all those applications, but here this is a exploit for a very specific type of specific class of applications, and you can go look at this code. It's actually like crazy, very complicated code, and but understanding how to control this, how these different things are used, that's what the idea that you're learning in the file struct exploits is. So that same idea of so if I know that I can, let's say, overflow into an object, or I can cause a use after free or a type confusion type of thing, what can I do with that, right? That's reasoning about what other types of code there is and other types of vulnerabilities. It's super important. And that'll apply on Windows as well. Similar things of allocators, so understanding and studying how the allocator works, it's going to be different, right? So you have to be okay with getting rid of like the low level, like, I don't know, oh, I memorized this exact house of whatever thing, but that's not going to help you. That's not as important as understanding the why. Why did that house of force actually work? What behavior in glibc was that allowing me to do? And how can I, as an attacker, identify those things in Windows? So that's my first thing, is like, the way to be successful on a new platform, something like Windows, is to bring your ideas of what should be possible and how to do things. So other things I get familiar with, if you haven't ever used Windows, I guess I would get familiar with it and use it. Some important things for reversing, if I remember correctly, is let's see, man, I kind of don't want to just spew off random things, but maybe I will. I guess the latest one is 7. I guess, let me see, an 08. Yeah, Vista. Windows XP is like my Windows. That's the Windows I grew up using that I very much enjoyed. Okay, but there are several, just like any system, right? And I think a lot of what you'll be doing is Googling, like, hey, how do I do X on Windows, where X is something that you did on Linux that was very easy. For instance, like, hey, how do I see what open files this process has? And I guess I should say a lot of my knowledge of Windows actually comes from, I think, basically two things, like doing CTFs. It was much more common to have Windows reversing challenges back in CTFs. This is because many reversing challenges came from not exploits, but specifically like reverse engineering malware. And so there's a whole bunch of things of like anti-reversing and all that stuff. Those all showed up in CTF, so you had to be ready to reverse on Windows. That still happens today, but not as frequently, I think. And I also took a graduate class at UCSB that was taught by Chris Krugel And in it, we wrote some like malicious Linux Windows kernel drivers. So we understood how to like basically write a rootkit to hide ourselves from other processes. It was pretty cool. But anyways, important things are going to be like figuring out what's going on the Windows system. Um, and there's a whole so Windows, obviously one of the key things about Linux, and one of the reasons why we use it starting with Pwn College is it's one of the most used server platforms for running things, so it's very useful to understand how that works so you can develop and run software. But the the other thing is it's actually open source. So Connor has done this several times of creating things and actually going in and like we see that some behavior has changed in Linux, or actually in several cases we found bugs in Linux that trigger this massive slowdown under certain conditions. And so we are able to identify those exactly because we have the source code of Linux and we can read it and kind of try to figure out what the bugs are. Windows is the kernel is completely closed source, right? So, or more or less closed source, is intended to be closed source. So there's actually a company, I guess the company was Winternals, but yeah, Sysinternals is the name of the website. So Sysinternals is kind of oh cool. This was a books. Yeah. So if you I guess it's called just Windows Internals. Yeah. This is like one of the best books if you want to understand the Windows kernel. You can understand the architecture, components, debuggers, all that kind of stuff. I mean, it's got like amazing stuff in there. Like you really want to understand how the Windows kernel works. Again, this is going to help you necessarily exploit a system, a user space thing, but this is incredibly important. Yeah, so this company, I believe, either Windows bought, so this is why we're on Microsoft.com. I think they bought this company because it was so like I don't know, they knew so much about Windows from externally, and sysinternals tools. They also had a series of tools, the sysinternals suite, that for sure look like you have it all here. You can download it for I don't know what the heck Nano server is, but you can get ARM64 or yeah ARM binaries. And so tons of cool things in here, things that you would think or hope would be built in that aren't necessarily. So I'll cover some of these. I think Sysmon was a great tool that, yeah, System Monitor. It yeah, let me see. Oh, I guess that's just logged services. I'm trying to think of Procmon is what I'm thinking of. Yeah, they had a bunch of things in here. I'm trying to think of what are the good. Ooh, blue screen. That sounds fun. Um, Diskmon shows you what processes are using this. Oh, Process Explorer, Process Monitor, Procmon, Process Explorer. Anyways, like super juiced up versions of different tools. So like Process Monitor. Oh yeah, this is what I remember. So you can see like for each process, like this process name here, you could get its ID, the architecture is running as 64-bit or 32-bit, what files it had open. So this was super useful of seeing what things we're reading from. Almost like like an strace style thing. This actually is really useful for that. And actually getting good at these tools is really helpful. Just like understanding, when you're part of what you're doing is not just learning how to exploit Linux binaries, but how to debug Linux binaries, how to reverse and understand Linux binaries. And that stuff is really helpful. So when I had a job at Microsoft, I actually knew these tools from my CTFing days, like the sysinternals, process monitor, these kind of things. And it helped me debug issues that we actually had with our software, where I think I was able to figure out that like some install of our software was broken because it was so the Windows registry was messed up and it was getting the wrong registry values, and that's why the customer was having problems. And so I was able to actually figure that out. Process Explorer. Ooh, this is interesting. Yeah, which program? Yeah. So this also shows you like the handles and DLLs that things have opened or loaded. Anyways, I would highly get familiar with these tools. These are super useful tools. I'll check with Rob. I'll actually just ping him now, see what's he is offline. To see what's actually installed on the Windows boxes, but if it's not, I will ask that these things be installed. Things that you'd be familiar with, it's strings. This is another big thing that is a big difference between Linux binaries. So Linux binaries almost always have ASCII strings, but most Windows systems, like their executables and object files, if you run strings on it, will not find anything because they frequently use like Unicode strings. And I believe the Windows format is like 2 bytes per character that it uses by default. So it's not UTF-8 Unicode. It's what's Windows Unicode? Yeah, I think it's UTF-16. Yeah, before 2019, Microsoft identifies UTF-16. Oh, it's recommended to use UTF-8. Interesting. Huh. UTF-8 is the universal code page for internationalization, and UTF-16 a unique burden that Windows places on code that targets multiple platforms. Oh, cool. So they are actually, Anything else? Okay. Yeah, but lots of binaries are Unicode. So if you run strings on them and you're only using ASCII characters, I believe you won't find any strings because of that. That's why these PS internals had to, or sys internals had to create this thing. Anyways, all kinds of cool stuff. And then let's see. Okay. So yeah, figure out like the tools, right? So similarly on a binary, especially thinking about reversing, you get it, you don't know what to do with it. You need to be able to understand what it's doing. So these tools are like the strace of those tools. So it's like the lower level. Then, other things you want to do, you need to be able to debug things, right? I don't know if people still, Ollie debug is the one I remember using a lot in Windows. Development is frozen. Sorry. Oh no, it doesn't do 64-bit. Oh no. Oh, that makes me sad. Interesting. Okay, they say x64 debug is the better debugger to use. It's open source, which is great. 64-bit, 32-bit debugger. Aha. Oh, I think the interface looks very similar. Huh. Ooh, fully customizable themes. Gotta love that if you're into... So, yeah, you got to get more comfortable so you don't have what I think of as your nice GDB interface that you can customize and do cool stuff. But here you can even see that like, okay, we're breaking right here. You can see like the memory addresses, the specific bytes, what on the right they correspond to. Looks like this is using Intel syntax, which is great. Should be very familiar to you. Subtract 28 from RSP. Call this, and then add. Oh, interesting. Yeah, Windows uses a different calling convention too, so that's another thing. What I think, hopefully, what you'll find is that you really enjoy learning a new architecture. Helps abstract your understanding of what's possible, right? So you realize like, oh yeah, calling convention is just it's a specific way on Linux. It's not like that all the time. Let's look up Windows. x86 calling convention. The x86 application. Oh, excuse me, I'm gonna sneeze. Sorry. Okay. Uses a 4-register fast call calling convention by default. Space is allocated on the call stack as a shadow store for call leads to save those registers. There's a strict one-to-one correspondence between the function call's arguments and the registers used for those arguments. Any argument that doesn't fit in 8 bytes or isn't blah, 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 must be passed by reference. Oh, interesting. Oh, isn't a multiple of those? Yeah, that makes sense. Okay. Blah, 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 blah. Integer arguments are passed in registers RCX, RDX, R8, R9. Ooh, see, those are different registers, right, than we're used to. Let's see, x86 calling convention. Yeah, so let's... Yeah, so we're used to the System 5 AMD 64, which is used Solaris, Linux, FreeBSD, Mac OS. That's right. Yeah, cool. Okay, so Microsoft, there we go, Microsoft x86. So this is, again, something you'll have to be, will be different, right? RCX, RDX, R8, R9 is the arguments for integer, struct, or pointer arguments, floating point argument, and then additional arguments are pushed onto the stack, right to left. Integer return values are returned in RAX. Let's see, structs and unions. Oh, interesting. Yeah, okay, that's what we saw there. So if something is a multiple of a byte size, it's passed as an integer. In the Microsoft x64 calling convention, it's the caller's responsibility to allocate 32 bytes of shadow space on the stack right before calling the function, regardless of the actual number of parameters used, and to pop the stack after the call. Interesting. The shadow space is used to spill RCX, RDX, R8, R9. Interesting. So 8, 4, 32. It must be made available to all functions, even those with fewer than 4 parameters. Huh. These registers are called volatile, non-volatile. Fascinating. So then as you're, this is why you study this and learn this, is as you're writing shell code, let's say, or something for Microsoft calling convention for Windows, you need to, like, if you want to call other functions, you need to make sure you're storing things in RBX, RBP, RDI, RSI. You probably don't want to use stack pointer, SP, R12, all 13, 14, 15, because otherwise these, if you're using these values, they can be wiped out. Shadow space is interesting. I wonder what this is doing to like performance, but whatever. So anyways, back to the debugger. So here we can see on the right, we can see all of the stack, not the stack, the registers and their values. If they point to anything on the right, we can see that there. We can see it looks like a call stack over here in this block. Down the lower right, looks like some memory regions. And yeah, there's other regions here. I don't know exactly how these are working or what it's showing. Oh, that's RSP maybe. Okay, yeah, so time wasted debugging. Wow, oof, was not a number you want to know in your life. Don't think about what your number is for 598. I think it's definitely all useful time. Okay, cool. So figure out a debugger. I'm sure we have something installed. But use a debugger. That's gonna be key. And you know this, right? You know what works for you. You know what how you like to do things as you're understanding things, reversing them. That's exactly the what you want to do. I guess you can also like patch things in here, which is pretty cool. Yeah, let's see. Other things. Okay, so debugging obviously very important. Depending on how far we go with this stuff, because again, like I said, reversing is one of the ways that I know Windows challenges. There's a lot of anti-debugging things, and so you may have to knock those out or or do other techniques that you've done. They're much more prevalent, I think, in the Windows reversing world. Because it just tries to emulate real-world malware techniques. Yeah, just had a cup of coffee. It's already fading. Okay. So we went over different calling convention. We went over this. What else do you need? Let's see. Coding probably shouldn't be a problem. I mean, you could just write your code in whatever, figure out how to compile it. That's, again, I don't think something that's that crazy. Yeah, debugging really important. Um, oh yeah, you'll want to use, I mean, something reversing tool, right? So again, you should have, I believe, should be the case that every single reversing tool you've used in this course, IDA, um, Ghidra, IDA, Ghidra, and anger management, and maybe soonish Binary Ninja, is that those should run on any platform. So you can run them maybe in the Windows VM, you can run them locally, whatever. You should be able to run those, and that'd be great. So yeah, that gives you the static analysis, of course, so that you're able to do that. And again, you're able to use exactly the same techniques that you did before. Oh, there's other things I want to. Okay, great. So Windows, there's another big difference. Not the calling convention. Yeah, so let's see, Windows. If I remember correctly, all right, well, this is kind of annoying. Okay, cool. There's definitely a difference. Oh, I think as you start reversing things like get proc adder, yeah. So MSDN, like the Windows, like the online documentation. Actually, fun fact: when I worked at Microsoft many years ago, the team that I worked on was inside Windows Server, and we worked on the user assistance team, which helped build, so manage tools that the technical writers could write their help content. They could end up inside of a help file. So when you hit F1 in your Windows app, it brings up a help menu, and that same help could go here on like MSDN. So, oh, good. Okay, so yeah, this, and so I think like at the time, 80% of the technical content on MSDN went through our systems. So, anyways, this is kind of like these are all of the different Windows functions. This is the big difference. A lot of these things appear to be like system calls. So you do something like get proc address that retrieves the address of an exported function from a dynamically linked library. So this is actually a common malware technique of load library A. So load the specified module into the address space. So the way, and you got to kind of start reading these. This returns some opaque handle that you don't know what it is. Just think of it as a void star. This H module. You call this function load library A, and then it'll specify in brackets here input and output parameters, saying what data goes in. So this LP lib file name would never be, should not be changed at all. Out parameters will be written to. You can think of this as like your built-in man pages. So when Rob tells you to go to the man pages, this is what you should do to read these functions. And so you can see that this is a library file or a DLL. This is basically how you do, like, you can do automatically dynamic linking in Windows of loading a DLL and then getting the address of a function. So for instance, if you want to evade static analysis and start loading things at runtime, this is how you do that. the name specified, blah, 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 blah. Yeah, cool. And then you can do that to get a name. So you want to call some procedure of that DLL that you just loaded or exe. Call this get proc address. It returns this var proc, which I don't know. The return value is the address of the exported function or variable. And again, two input parameters. This LPC string, God, I can't remember exactly what that is, but these are all like Microsoft types, and you can look it up here. Yeah, so it's a type def of a constant character pointer. So it's just a null terminated string of 8-bit ANSI characters. Oh, you can see all the types here. Common data types. So this is something that's probably useful to observe that you'll see a lot. I definitely did not spend time to like memorize exactly what these are. A D word is a 32-bit unsigned integer, so Q word or a quad word would be a. But I think these are the default things that are like built into IDA because IDA was made for reversing Windows stuff. So that's why you see a lot of the time in IDA these things like D word, Q word, all that kind of fun stuff. MSDN link. Oh, goes right here. Crazy. Okay. Cool. Oh yeah, so get proc address, parameters, input parameters, so a C string of the procedure's name, return value, what to do with that value. Now, the interesting thing is, you can see this is in the libloader API.h, system services. Let me look. System services versus kernel Windows. There's something interesting, and I'm trying to look it up. Windows. Yeah, so let's see. Virtual addresses. No, I want to, okay, so I believe a lot of things, yeah, but this is all stupid. This is all Linux crap, okay. But in Windows, so one of the big differences is that a lot of these functions like get proc address and what was the other one we were looking at? Get proc address, oh yeah, get module file name, get handle, all this kind of stuff. These actually get called into a library, so something that also runs in user space. And there are some system calls that actually go to Linux, but they are very complex, if I remember correctly. This I already looked up this, the boundary diagram. Yep. Okay. So when you launch an application, it creates a process. This process has the virtual address space and a private handle table. Since each application virtual address space is private, blah, 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 blah. Right. So virtual address is similar. Process running in user mode can't access virtual addresses that are reserved for the operating system. Yeah. All coded in the kernel shares a single kernel address space. Okay, but like I want. Yeah, so the Windows API. So that's the difference. So yeah, a lot of applications will talk to this Windows API, and that will then talk to the kernel. So where? The Windows API. Yeah, there we go. Oh yeah, Win32 is 32-bit. Yeah, okay, cool. Base services provides access to the basic resources available in a Windows system. Included are things like file systems, devices, processes, threads. Yeah, kernel.exe, kernel 32 DLL, and kernel base DLL. Cool. Registry things, graphics, user interface, the web. If you really want to get into stuff, you can start learning about COM and OLE and stuff, but that's like, honestly, kind of crazy stuff. Windows API versus kernel. See, this is how I just do it. Yeah. This person doesn't know what they're talking about. Yeah, okay. So moving forward, system calls on Windows are performed under the hood by the native API, which implemented NTDLL and mainly undocumented. Public API installed by Microsoft, such as the Windows API. Yeah. It does malware directly call. Cool. I guess I don't quite know exactly how the system call process works, but oh, there we go. Stack filled with parameters of NT create session. Oh, fresh copy of NTDLL. EXE register has NT create session. It's called hex value, taken from a fresh copy of NTDLL. Sys enter or int. Oh, there we go. From this question, how does the Windows native API communicate with the kernel? Great. So yeah, so that's the idea is like, rather than where Linux defines the system call boundary and says, okay, if you are writing a user space application, you want to use functionality of the kernel, here's the function, here's exactly precisely how you do that at that boundary. What Windows has done is put a library in the middle that said, okay, here's this library, this Windows API that you can use, and that knows how to talk to the kernel, but you should never talk to the kernel, so that way we can change how we talk to the kernel and make it faster or better or whatever. And that way we're not, the kernel user space interface between NTDLL and the kernel is not fixed all the time. Oh, cool. So here's an example of ZW close, the system call on ntdll.dll. It moves RCX and R10, 05 into EAX, move 1, test that, then syscall. Oh, this is deciding whether on this to do a syscall or a int hex 2e. Interesting. Oh, interesting. So it's some debug thing. Okay. Int 2e is used on 32-bit OS to enter the kernel, and 64-bit the same as obtained by using syscall. Okay. The Windows native API is a user mode library. However, it is the final user mode library that interfaces with the kernel. How does it actually interface with the kernel and bridge the gap from user mode into kernel mode? For example, if I write a standard user mode application, I cannot directly call this function. Yeah. So there's nothing, no like privilege separation thing. It's just to help you. So malware can directly call into the kernel. The applications can do that, or they can use these libraries. So oftentimes you will be like, I think for this stuff, you'll probably be at this high level where you'll be reversing this, what we'd call the Win API functions. Yeah, so Win32 API. And yeah, you can kind of see there's like so much stuff in here. Yeah, these are the different. Ooh. off. Virtual disks, power management, memory management. So yeah, basically like Windows requires a lot of either reading about what things do or trying things out. Like Rob is really good about developing an example to do that. Your C code, if it's written correctly and to the right standard, should work on both. So that's good. You can use the stuff that you've been building up. That shouldn't be a problem. But double check with the man pages, right, of what the actual things say. Let's see. Other things that, I don't know, I guess if you've never used Windows before, didn't grow up using it or playing with it or breaking it, should probably specify a DLL is I think it's a dynamically linked library. Yeah, dynamic link. I still feel like it should be dynamically linked, but anyways, a dynamic link library. So a library that is loaded at runtime. This is like a dynamically linked binary on Linux. So you can have a program, it specifies all the DLLs, all the dependencies that it has, and then when it runs, those are loaded into memory. You'll definitely want to check like the different types of what's the word I'm looking for? Win64, interesting. Cool. Okay. Yeah. So DLLs. Oh, cool. So there's actually like a nice diagram. And this, if you ever wondered about how, what's that thing called? Windows Subsystem for Linux, WSL, works. And POSIX compliance and all that stuff is basically, you have these different subsystems and it basically translates your calls into the kernel mode. Wait, why is the Win32 application? Okay. Yeah, so your POSIX syscalls, when you're doing that, that is being probably hooked or caught or something and yeeted over to the kernel to do whatever it needs to do. Cool. All right. Any other Linux or Windows questions? Let's see. What am I forgetting? DLLs. All right. Holler. Let me know. Drop a message in the chat if you have a question or something. Otherwise, I think I've hit everything of what to be on the lookout for. Basically, for this, for sure, like start early, just because you want to make sure that you're starting with enough time to, like, part of it is just learning the tooling and getting up to speed on the tooling. So if you're behind on that, it's going to definitely take you a long time. So put the time in to do that. Read the man pages, look up any types you don't understand or common data structures or UINT 128. Oh, interesting. Yeah, makes sense. Cool. All right. I think with that, I've exhausted everything that I vaguely remember on Windows. Hope it was helpful, and good luck with your assignment.